Tonight, the Planet 9 hypothesis, why some astronomers infer a distant, massive body in the outer solar system, why others argue the signal is biased in small number statistics, what the sky surveys actually see, and which tests can settle it. What is claimed a super-Earth scale object, roughly 5 to 10 Earth masses, on a highly elongated inclined orbit hundreds of AU from the Sun, could explain the unusual clustering and orbital tilts of several extreme trans-Neptunian objects, ETNOs. The claim is statistical. Add one distant perturber, and certain patterns in minor planet orbits become more probable. Key observational inputs: ETA Aoyane, clustering. Several distant objects, perihelia, 30 to 40 AU, semi-major axes, 150 to 250 AU, appear to have arguments of perihelion and longitudes of perihelion that bunch together rather than randomize. Orbital planes. Some ET nodes share similar longitudes of ascending node and exhibit a common tilt relative to the ecliptic. High inclination outliers. A few bodies with very high inclinations, including retrograde examples, are difficult to produce with Neptune alone. Detached orbits. Objects with perihelia so large that Neptune's present perturbations are weak suggest past or ongoing forcing. Mechanism, if real. A distant, massive planet on an eccentric, inclined orbit can secularly torque smaller bodies, aligning their perihelia, trapping some in anti-aligned configurations, exciting inclinations, and producing detached orbits via long-term gravitational interactions. The effect is weak per orbit but coherent over hundreds of millions of years. Counter-arguments. Survey bias. Wide-field surveys do not scan the sky uniformly. They favor specific ecliptic longitudes, latitudes, seasons, and magnitude ranges. Clustering can emerge if discoveries occur where surveys look deepest. Proper debiasing requires each survey's pointing, depth, and detection efficiency as functions of sky position and rate of motion. Small n statistics. The number of extreme objects is still small. Apparent patterns can vanish as samples grow. Alternative dynamics. Past migration of Neptune, resonant sticking, stellar flybys in the Sun's birth cluster, and self-consistent models with many Neptune crossers can produce detached or misaligned orbits without invoking a new planet. Time evolution. Secular patterns drift. A snapshot can look clustered even if long-term distributions are broad. Data quality and debiasing. Modern surveys publish not only detections but also where we would have found an object if it were their maps. With these, analysts can weight each discovery by detectability and test whether clustering survives. Results are mixed across groups. Some find statistically significant alignment after debiasing. Others report consistency with noise once the same selection functions are applied. Search constraints on Planet 9 itself. A super-Earth at hundreds of AU would be cold and faint. It could be missed if currently near aphelion, at high ecliptic latitude, projected against the Milky Way, or simply below the magnitude limits of completed sweeps. Infrared all-sky surveys constrain warm giant planets. Reflected light searches constrain smaller, colder bodies. The allowed parameter space has shrunk but not closed. Orbital solutions proposed. Nominal fits place the planet on an eccentric, E Brockwell 0.2 to 0.6, inclined, I Brockwell 15 to 30 degrees. Orbit with semi-major axis 300, 700, and A 300, 700 AU. These ranges shift as new ETNOs are added and as different teams choose different weighting schemes. There is no consensus ephemeris. Dynamical side effects predicted. A mild forced tilt of the solar system's invariable plane relative to the ecliptic. A population of high inclination retrograde TNOs produced via Kozai-Lidov-like cycles. Specific distributions of detached perihelia and resonant islands beyond Neptune. What would count as strong evidence short of imaging? A statistically secure, debiased clustering signal that strengthens as new ETNOs from independent surveys are added. Consistent reproduction of multiple observed features, perihelion alignment, inclination distribution, detached fraction, by one set of Planet 9 parameters across many realizations, while alternative models fail those joint tests. Independent, prediction-validated discoveries, e.g., forecasting regions of sky where new aligned ET nodes should appear, then finding them at the predicted longitudes and inclinations. What would falsify or strongly disfavor Planet 9? D-bias catalogs from Uniform, deep surveys showing perihelion longitudes and nodes consistent with random distributions. A self-consistent Neptune migration model that matches the full suite of distant object statistics, including high inclinations and detached orbits, without an extra planet. Stringent reflected light and thermal limits, ruling out the required mass-distance combinations across the remaining sky. Instrumentation landscape. Wide-field optical surveys. Ongoing and upcoming programs expand sky coverage, cadence, and depth, producing larger, better characterized TNO samples with published selection functions. Targeted deep imaging. Focused searches in predicted sky swaths, using long exposures and difference imaging to catch slow movers. Infrared constraints. Space-based reanalyses for cold, faint sources. Ground-based follow-ups for candidates. Orbit-fitting pipelines. Open tools that ingest detections, track linkage, astrometric error models, and bias maps to generate D-bias distributions. Dialectic. Two positions in brief. Pro-Planet 9. Multiple independent orbital anomalies line up under one dynamical cause. The parameter space for a distant super-Earth is not yet excluded. Predicted high-inclination populations and detached orbits are observed. As samples grow, clustering persists after bias corrections in some analyses. Skeptical. Apparent clustering is an artifact of where telescopes observed and what they could detect. Small number effects dominate. High inclination and detached objects arise naturally from resonance sticking and migration histories. No direct detection despite motivated searches. Related phenomena often conflated, clarified. Oort cloud comets. Their isotropic arrival directions are not evidence for Planet 9. They reflect a distant, roughly spherical reservoir perturbed by tides and passing stars. Planet X historical searches. Prior claims targeted different mass as semi-major axes to explain pre-Voyager ephemeris residuals of known planets. Those anomalies disappeared with better data. The current hypothesis is dynamical and statistical, not ephemeris-driven. Nibiru, doom narratives. These are non-scientific and unrelated to orbital dynamics research. Risk of confirmation bias and mitigation. Publish complete selection functions and null fields. Use pre-registered statistical tests. Blind the sky longitude of discovered objects during pipeline tuning. Require that clustering significance be recomputed by independent teams with independent code. Weight new objects by survey detectability rather than treating all discoveries equally. Concrete near-term adjudicators. Uniform, deep coverage of high-latitude sky reduces geometric bias against inclined orbits. Larger ETNO sample with well-measured orbits tightens clustering significance or dissolves it. Stack constraints in predicted sky sectors. Non-detections at required depths progressively exclude parameter space. Improve thermal models. Map planet brightness as a function of mass, age, and insolation to convert magnitude limits into mass-distance contours. Cross-survey. Open catalogs. Enable reproducible debiasing and standardized tests. If Planet 9 is found, expect a dim, slow-moving point source with consistent multi-night motion and parallax, a reflected light spectrum indicative of a cold, volatile-rich super-Earth mini-Neptune, and an orbit tying directly to the ETNO architecture. Follow-up would include color, phase, and thermal measurements to infer atmosphere and radius, and long-arc astrometry to refine mass via perturbations. If Planet 9 is not found and clustering fades, the null would favor models where Neptune's migration, resonances, and early stellar environment sculpted the distant belt. Attention would shift to reconstructing that history with better small body physics, including collisional evolution and realistic survey simulators. At issue is not nostalgia for undiscovered planets, but whether the outer solar system's architecture requires an additional perturber. The signal is statistical. The cure is data with disciplined accounting for where and how we looked. Either result, discovery or dismissal, will sharpen our map of the solar system's past. Coverage continues as deeper surveys report new distant objects, de-biased catalogs are released, and targeted searches clear or confirm the remaining sky.